Let's move into a new view, a totally different way of thinking about the motion. Now it's velocity view. These graphs no longer show us where the object is in time. It's showing us how fast it's going and in what direction. So let's go ahead and label this. This is now velocity. And this is time. This is the time axis. And you can ignore these. Those don't mean anything. So if something is moving at constant velocity in the positive direction, then it would have, let's say you're moving at 100 miles an hour in the positive direction, then your velocity would be, 100 miles per hour, one moment, and then one moment later it would still be 100 miles per hour. Whoops, not 1,000 miles per hour. And then one moment later, it would still be 100 miles per hour. And so that would be like starting here at 100, one moment later being 100, another moment later still being 100. And so constant velocity in the positive direction is just a flat line. Well, what if you're moving at constant velocity in the negative direction? That means that you're maybe going negative 100 miles an hour one moment and then staying there for a while. So that means you're going to be down here in the negative space. And just connecting those dots. Constant velocity in the negative direction. This here is zero velocity and zero time. Okay, what if you're speeding up? If you're speeding up, you would start at zero velocity. Again, this is the velocity axis. This is the time axis. So speeding up means that your velocity would be increasing. And this would be increasing at a constant rate. And if you're slowing down, it means that your velocity would be approaching zero. So starting at a relatively high positive velocity and then approaching zero, slowing down. What if, though, you were speeding up in the negative direction? Speeding up in the negative direction. So you're still going to maybe start from rest, but you're just going to move in the opposite direction. So that means your value would get more and more negative over time. And if you were slowing down in the negative direction, then that means that your initial velocity was a negative value and that you're going to approach zero. So now you're slowing down in the negative direction. If you are at rest, then your velocity is zero the whole time. So the big idea here is that the slope has a new meaning. The slope now means your acceleration. So here, zero slope equals zero acceleration. You're at rest. You actually have no velocity and you're not accelerating. Okay, let's add one more layer. So, by the way, as you move from position graphs over here to velocity graphs, you actually lose a little bit of information because a position graph not only tells you where the object is each moment in time, but from the slope you can get the velocity. However, over here in velocity view, you only get how fast and in what direction. You cannot see where the object is starting. So you can't like go back and grab the object's position from the velocity view. So we lose one layer of detail when we're going from position to velocity view.